Okay, we're here at gotomath.com. Click on the calculus. We're looking at numerical integration, and we're down here at Simpsons Rule 2.2, going from -1 to 3. Okay, use Simpsons Rule for approximating the definite integral n is equal to 4. Thing about Simpsons Rule, n must be an even number. To 4, that says 4 decimal places if needed. All right. So let's go ahead, go to the whiteboard, write that down, -1 to 3. And what was that, x cubed? Yeah, x cubed dx. All right. And so I'll just go ahead and write this up here. F of x is equal to x cubed. And we're on the interval between -1 and 3. All right. So we're going to go ahead and state Simpsons rule. We're not going to really get into the theoretical aspects of it. I'm going to state it, and then that's going to be it. All right. Okay, well, like most of the theorems in calculus, our function is continuous. And it's usually continuous on some interval. And that particular interval is going to be the interval AB. All right. Okay, so f is continuous on the closed interval AB. So we use Simpsons rule for approximating this integral here. And we'll just write this out generally, going from a to b, f of x dx is approximately going to be equal to this. And that is b minus a over 3n. Alright, and this is looks a lot like the trapezoid rule, except the coefficients are different, and instead of a 2 being there, there's a 3 there. So maybe that's what you need to remember. x1 plus 2f of x2 plus dot 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 plus, and then the last one, or the one before the last one, f of x n minus 1 plus, and there's always a coefficient. I'll write out the pattern here of what these coefficients should be. All right. So the pattern of the coefficients goes like this: 1, 4, 2, 4, 2, 4, dot dot dot. Last one, or the one before the last one's a 4, and then a 1. Okay. So these are the coefficients. Now remember, n must be even. And in the particular problem we're doing, n happens to be 4 subintervals. Our coefficients are going to be 1, 4, 2. Actually, I better write it down here. 1, 4, 2, 4, and 1. Okay. Where this will be x of naught, x of 1, x of 2, x of 3, and x of 4. X of 4 right here. All right. Yeah. Okay. So some things we need to know. Delta x is equal to b minus a over n, and that x of I is equal to a plus delta xi. So this is just like in the trapezoid rule, and it's like the right endpoint is what we're plugging into the function. Here, the right endpoint. Yeah. All right. So now, where are we at now? We are going to go ahead and find all of our x of I. So we're going to start with x of naught is equal to, so a is -1 plus, and of course I didn't get our delta x, did I? Delta x is equal to 3 minus a minus 1. Right, so that's b minus a over 4. I have now run out of room. So this is 3 minus, so this would be 3 plus 1, which is 4. and 4 over 4 is 1, so that's easy enough. Delta x is 1 times 0 is equal to negative 1, right? And then x of 1 is going to be negative 1 plus delta x is 1 times 1. Let's put a parentheses around that. And so that's actually going to end up being equal to 0. This is actually going to end up being pretty easy to deal with. Negative 1 plus delta x is 1. Plug in a 2. And so we're left with a 1 here. Okay. And then we have x of 3, negative 1 plus our delta x, which is 1. And now we have 3 minus 1, which is 2. And then our last one, x of 4, is going to end up being negative 1 plus delta x times 4. And so that ends up being 3. And it should be. We're going from negative 1, remember, to 3. Okay? Alright, easy enough. And I think what we'll do over here is we'll go ahead and work through this part right here. So f of x of naught. Now remember our function f of x is equal to x cubed. Alright. So our x of naught, which happens to be negative 1, so we just plug negative 1 in, cube it, and we get negative 1 out. And then we go to the next one. So this time it's got a coefficient of 4. F of x1 is equal to 4 times, and x of 1 happens to be 0. So 0 cubed is 0. Wow. And so then the next one's going to be 2. Remember, these are the coefficients here we're looking at. So 2 times f of x2 is equal to 2 times, and let's go over here, x of 2 was 1, so this becomes 1 cubed is equal to 2. And let's see, so we're now at that coefficient. 4f of x3 is equal to 4 times x of 3 is 2 cubed. So this time it's going to be, let's see, 2 cubed is 8. 8 times 4 is 32. Right? I hope. Alright, and then of course the last one has a coefficient of 1, so we won't write that. F of x of 4, and this ends up being x of 4 is 3, so 3 cubed is 27. Alright, so we got all of our numbers there. Okay, good enough. Alright, let's now come over here. Now remember, this was b minus a over 3n. So b minus a over 3n, right? And okay, yeah, b minus a over 3n. So remember, b minus a over n, we're going from negative 1 to 3. I guess I better just write this out right here. How's that? So b was, actually better write it out here. 3 minus a minus 1 over 3 times 4. Right. Okay. Now let's go through. So f of x, so all we're doing here now is summing up all of these guys. So we end up with the first one is negative 1 plus 0 plus 2 plus 32 and then plus 27. Alright, we're going to hold our breath. Hopefully not too long. And let's see what this thing is equal to. So I'm going to grab my calculator here. I'll let you do that in your head. Negative 1 plus 0 plus 2 plus 32 plus 27. And of course, I get a syntax error because I don't type stuff in right. Plus 2 plus 32 plus 27. So I get 60 for the inside times that by, that's just 1/3, isn't it? Times it by 1/3. Yeah, I'm getting 20. I bet the exact value is equal to 20 of that integral. Anyway, this is equal to 20 right here. And we were going from negative 1 to 3, if I remember right. X cubed dx. Okay, and we need to put approximation symbols here, 20. And I'm going to actually find out what the exact value is here. I don't know why I wrote a square here. This is supposed to be cubed. Okay, so I'm going to do that. So we have negative 1, 2, 3. I bet it's 20. It is. That's how accurate Simpsons Rule actually is. I've got an approximation symbol here because that's what the theorem states, but it turns out that Simpsons Rule is an exact number. It actually equals the exact value there. Amazing. Simpsons Rule is amazing. You want to compare that with the trapezoid rule. All right, compare that with the trapezoid rule. Anyway, so we end up getting 20, and 20 is actually not just an approximation, but it is the exact value. So, all right. So in the real world, we'd want to write a computer program to do that and let n go to a very large number. But in this case, it was sufficient enough, and being equal to 4 was good enough. All right. Okay, well, that didn't take too long. Come on by, go to math.com, check it out, and maybe I'll see you there. Bye.